Well, it's good to see your face again, Javier. After last week, you got a haircut, which is and
Yeah,
in an orange suit. So it looks like you
yeah,
might have just gotten out of the glass cleaning area in the laminated section.
yeah, exactly. I look like a
But
I look like a supervisor on the floor. I've got their uniform today.
Ingeniero Javier.
Ingeniero Javier, that's me exactly. Ingeniero. You learned some when you came down to Mexico.
I learned a lot in
Um,
48 hours.
yeah, there you go.
But
Miss
thank
Patty
you both for.
Miss Patty can explain more to you about it. She knows both cultures very well.
Well, yeah, she's the bridge between us in case there's
Right.
any miscommunication. So no, I'm excited to have you guys on. And what I really am excited to dive into is I think, Patty, you're a very strong bridge for Javier on the floor, doing his engineering business and what the actual architects and designers and design community wants and is in demanding in today's climate and in the way architecture is going today. So, I guess before I start diving into the questions, let's do a real quick introduction. I'll let you start, Patty, and then you, Javier.
Thank you.
Okay. All right. Well, my name is Patty Yanez, and I've been with Krista Curva now 13 years, and I've specialized with working with architects, designers on the design side, and working on specifications on any special glass needs. Started off in the decorative line and moved on to our other products that we offer: oversized, lowy, IGs, curved, anything unique, structural. And also work with the sales base, the glazers, the customers. So I'm kind of all over the place. So I do a lot of the architectural technical assistance, but also on the sales. So I kind of consider it architectural technical sales, so to say. So that's basically what I cover.
So my name is Javier Sánchez-Gil. I've been with the company for 33 years this year in May. I started in the sales area and moved into the operations a few years ago. And my responsibility today is actually that the operations of the company and the sales, both things. That means production, everything has to do with the producing the product to selling it. So the sales teams and the production team report to me. I've had the opportunity throughout the years to work with in many projects, very different projects. I work with architects, glazers. I work with our team internally, develop a team, work with suppliers, and it's been a very nice trip. And here we are today, in Krista Curva, and trying to do fun and interesting things for good looking buildings.
Yeah, it's a good way to put it. So I don't want to explain it through my mouth. I want to hear how you guys explain it to people. How do you differentiate to somebody what a glass fabricator does versus what a float glass supplier does? Because people look at their buildings and look at that Guardian building, look at that Vitro building, look at that Saint-Gobain building. I don't think they realize what has to happen between that float glass production and curtain wall production. There's a huge gap between there and a lot of magic that happens in Guadalajara behind the scenes. So how do you explain to somebody what an IG fabricator is and the significance of carefully selecting the right one for the project?
So I think that's a really good question. And even throughout all these years, we still get that. People always ask us, do you coat the glass? Do you, how does it work? Do you just insulate the glass? So it's basically all falling in line with what you're asking. So what we basically let them know is that we buy the raw glass from an actual manufacturer that makes the raw glass, and then it's either tinted, coated with a special coating or an etching or a frosting of some sort. We buy the glass in big sheet sizes. They're brought in large trucks, containers. The glass is obviously going to be based on the requirement for the project, the best optimization for the job, as far as sheet sizes go. And if we have to go larger just because the jobs require larger sheets, that's just what we do. So the glass basically comes in on a truck, and then we offload it, and then we take it from there. And then all the processes to making an insulated glass unit, and then shipping it out and going to an installer to glaze it. So that's when we let them know what we're in charge of is cutting the glass, doing any kind of edge work and polishing. We do obviously the curving of the glass, whether it's a curved annealed format or curved tempered, or it's just tempered glass. We do, the digital printing in-house, any silk screening, any sort of patterns like that. And then we also insulate the glass. laminate the glass, insulate the glass, any type of holes in fabrication. We get asked about that as well. All that happens before the tempering process. So we have to explain it step by step. The main thing I like to let them know is that once the sheets are coated and encased and shipped out, then we take it from there. And then that's when we become, responsible for the glass and getting it out in the correct format and makeup for the client.
So if I look at a building, the correct answer as to who did the glass it could be the installer who installed the glass, it could be the fabricator who fabricated the glass, and it could be the manufacturer who manufactured the glass. So technically speaking, all three could be right because I installed the glass, but glass was fabricated by Patrisia, and the glass comes from, you name it, Guardian, Vitro, whoever. So technically speaking, you could say that the answer is correct as long as you're not saying that you fabricate a piece of glass on a building that you didn't fabricate, or you made a piece of glass on a building which you didn't supply. But technically speaking, that's correct.
Well, many people play a part there's a lot of people that play a part in the process, obviously, but I think the IG fabrication process is not scrutinized enough, and especially in the project typology that you would be exposed to, where you're dealing with something atypical, whether it's a size or a makeup or a shape or geometry. I would think there's a higher level of scrutiny around the fabricator selection process. Would you agree?
I agree. Just in all the processes I just explained to you, there are parameters in place, tolerances in place for each one of them. So there is scrutiny in between all of it. What we're doing with the glass, we're heat treating the glass, we're curving the glass, we're laminating it. So you've got a lot of deformation of glass. So there's a lot of aesthetic qualities involved with all of these processes. So all of that is considered and scrutinized because you may not have an actual calculation or a figure of what you're looking for on that particular application. And tolerances even from just cutting the glass, where your holes are placed, the insulation, where your silicone, your secondary seal, you've got a spacing for that. So each one of those processes have their own tolerance. So I do believe that we are the ones that really have a lot of responsibility on our hands.
Correct. I would say that we do get a lot of scrutiny, which we welcome. I think it's very important for our customers to make sure that they're going to get a quality product and the product they want. So we welcome the scrutiny. But I would like to add something to what Patty said, though. There is a very good level of research, of development, or of scrutiny, to use the word again, when it comes to coatings. And we don't make the coatings, but that's because of not so much because of quality, but it's more because of color. So I would say that the scrutiny of the coating with regards to color or reflectance, that's number one. And number two, obviously, is how much quality do you put into a unit that is going to last there for a very long time in a building and it's going to look beautiful and clean and crisp. So those are the two things that I would say.
I spent the first 5 years of my career doing site inspections for curtain wall installation and visually inspecting the curtain wall units when they lay them down on the floor to make sure there's no discrepancies or discrepancies from the contract documents before they set it on the building, testing the interfaces and the splice joints. But by the time it's already on site, the unit's been glazed and what's been built's been built for the most part. So you could flag issues, but you're going to have to deglaze the glass, send it back to the factory, and get a replacement unit. Are you surprised that there's not more visual monitoring or inspections done in the glass fabrication process or during that period?
We've actually encouraged that, and we've seen an increase in inspections during fabrication process. We have a lot of visitors that come to the facility now. An entire project team will come, and they will even come from the very beginning when we're trying to maybe do a prototype or a mock-up of some sort, just because it's so unique. And they may go out and visit several other fabricators, and they're looking for a certain look and looking to see how you're set up and what quality assurance measures you have in place. So we will have visitation during a fabrication of a prototype, a sample. We will have a visitation during an actual mock-up. We do setups with framing, really large units in the facility or outside, depending on the type of setup or framing. We work together with them so that they're able to come out and look at that. And then some of them actually want to come and see during the fabrication, the lamination, the insulation, a certain part of it. I think because there's a lot more hands-on now and the expectations because they know what's possible because someone else is doing it. And a lot of people have said they can do certain things. And it's easy to say you can, but to actually prove, I think that's why I've seen a lot of increase in people wanting to come out. And just like I was saying, I mean, we have visitations all the time and we welcome it because we want them to understand, what it takes to make that glass. Because while I may explain the process of cutting a piece of glass, there's a science even to cutting the glass. It's putting a hole, laminating the glass, the whole assembly, maintenance, having clean rooms. I mean, every single aspect of it. It takes a lot. And I think when someone actually puts their eyes on it, they really will respect the process and understand it more. And I think it helps. It's really, really imperative to do a lot of that collaboration, which is something that Javier has talked about quite a bit and we feel is really, really important. So yeah, if we don't see other fabricators not doing it as much, it would surprise me because we are definitely seeing a lot of increase in that.
Yeah, I mean, a standard laminated unit, which we see everywhere in New York because of acoustic requirements, or you go to Florida, you see it everywhere because of impact requirements. I think watching the curving was awesome. And, we'll go into more specifics on that. But an appreciation for the laminating process, just given the level of scrutiny around handling and cleaning to make sure that you get clean substrates before you apply that inner layer. And then the process of dehumidifying the assembly, it was a very meticulous process and required a lot of attention to detail. Which, unless you see a lot of this, it's hard to get an appreciation for.
Right.
So, Javier, I'm gonna age you a bit here and date you, but when you were younger, when you really started out selling in North America, when did you really start seeing the advent of insulated units becoming commonplace? When you started out, was it a lot of monolithic glass?
No. When I started, IGs had already taken off in the US. Laminated glass was still in their growing stages or was being born. I mean, it wasn't being born, but a lot of people were laminated already, but it wasn't as commonly used as it is today. But no, IGs were already there. I'm not that old, man.
Well, yeah, well, no, I mean,
I'm pulling your leg. No,
but even in
yeah.
Mexico, the fact that thermally broken frames is not commonplace.
Well, you're right. I mean, yeah, in Mexico, I was talking about the U.S. market here. Yeah, in Mexico, no, you're correct. In Mexico, when I first started working in the market, talking to customers and so on, IGs were not common at all. It was only monolithic. Not even temper was common. I mean, tempering was starting. Nobody would laminate in Mexico back then. I mean, there were a couple of very, very small lamination facilities, and that was it. So everything was monolithic, annealed in Mexico. In the U.S. market, IGs had already taken off. Laminated glass tempered glass was already there, big time, and laminated glass was in its initial stages compared to where it is today, I would say.
If you think back to a defining project when it comes to commercial architecture and curving that puts you on the map or really started getting you attention or where you really started getting inquiries, what project comes to mind?
Oh, we did a very beautiful project in New York that was in 2001, right after 9/11, actually. It was a small hotel. It has changed names ever since, but it's still there. It was a beautiful storefront which had curved glass. It was curved laminated. I want to say it was insulated. I can't remember. No, it was not insulated because it had holes. And we also ended up doing a canopy with flat glass and in a storefront with flat glass. That was a very beautiful small job that we did. For us back then, it was a huge job, right? Today it's a small one, but it was a beautiful one. It's still there. So that comes to mind in New York.
So you were set up with the equipment and everything to curve at that time. It's something you wanted to be selling.
Yes, yes. We started curving glass in a way that was, I could say, was well done in the late 80s, mid 80s. I wasn't there, or I wasn't around at the time. I wasn't working. I mean, I was born. I wasn't around. Around the early 2000s, we invested into curve tempering, which was very, very new at the time. I mean, I think it was only two of us or three of us or maybe four of us in the world doing it. If you compare that technology to today's technology, it was very basic technology, but it allowed us to do curve tempering. And obviously, I mean, curved glass was already a very small niche in Mexico, and so for us that really pushed us to look for new markets, and the closest market to us that made sense because of its size and its needs was the US market, and obviously sophisticated cities like New York. So that's why I think everything coincided in us going into to doing this job, which was happened to be in New York with curved tempered laminated glass. So
I'm going to
yeah.
get to, the intersection today that you deal with, Patty, between architecture and performance. But at that time, Javier, was it all about the look? Was that the driving? Because energy codes and people didn't really know what that meant or know what it was. Even go back to the late '90s or early 2000s. So what was really driving the architecture then?
It's always been about the look, and it'll always be about the look. Now, you have to add also performance and other things, but it's the looks. I mean, architects want the looks, and that's what we're here for. I mean, we're trying to make beautiful projects. I tell people that what we do here, we do the bride's dress. Every bride wants to look beautiful, and every bride wants to have a different dress than the previous one, and that's what we do. Everything is about the look. Now, the dress has to meet certain standards so it can last. And I don't want to go there because the analogy is not going to work in this case. But yeah, it's about. I mean, what we do is about the looks.
And so fast forward to today, I mean, Patty, are a lot of your conversations focused or derived from performance or aesthetics? I mean, I understand it's a balance of both, but what are really the driving factors today?
The driving factor, I will agree with Javier, always has to do with the aesthetic. It's the look, what the scheme they're trying to achieve, the overall combining any other components or elements, so that how the glass would fit into their vision, because that's what they're envisioning. Basically, I would look at performance as, well, that's just the law we have to follow. Just like I'd love to drive a beautiful car, a fancy foreign European car, but guess what? I got a seatbelt on, so it doesn't matter. So that's basically it. The architect wants to make sure it's got the look, but they understand too the requirements, and that's what's important is that it falls in all of that, so that they are able to provide a product to the client, and we're able to guide them with something that falls within the vision, but again, won't get anyone into any kind of trouble or issues trying to submit or bring something that wouldn't work for just necessities of requirements of safety and codes and stuff.
So over the years, wanting to be relevant and having to pivot depending on the market needs and competitors and market driving factors, how has it shaped your thinking in terms of setting up the factory and sort of standard offerings? So, if you want to be a big supplier in Florida, there's no way around being able to, you have to be able to laminate. We spoke in the factory about having a heat soaking oven. It's something that some people offer, some people don't. So just in terms of the standard offering have some of these steps along the way just become, in your eyes, a requirement to be relevant today? There's just no getting around it.
I think it is like, you want to be able to provide certain products, you got to be open to it. Like you talk about the heat soaking. Another thing, bird friendly. That's another one. You want to be able to provide glass in certain locations for certain buildings in certain areas. The criteria requires a bird friendly product. So you've got to look at different options of seeing, okay, how much of a demand or need, what can we do to bring that in? Going larger. Obviously, we've always, part of the name of Crista Curva is advanced technology glass, and we're always looking for the newest, Don't want to be the first. It's not good to be a guinea pig, right? But you want to see what's out there and what's available as far as in the technologies go, like you were mentioning earlier. But with heat soaking now, just everybody sort of asked for it. It's just kind of been embedded into specifications now, like a regular composition or requirement. But yeah, it's definitely, I think a lot of it where we are is driven by that, for sure. For sure. And one of the things I did want to kind of go back and add about what the architect's wanting, and I think that we really can stand out compared to other fabricators, is that when there's a requirement for code, the glass, you have your options of glass coatings, right? And each coating has its performance numbers. It's got its ratings. It's not like you can budge from there. But what really stands you out is that you're able to provide the look and provide the quality and those subjective aesthetic tolerances that the architect is envisioning. And that's what makes you stand out, is that part. So the fact that what the architect is looking for is on the look of it and design of it and the quality. And that's what I think has been really good for us. And it's definitely helped us in being able to be successful with them.
In somewhat being it's the equivalent of being a custom curtain wall or custom fenestration supplier. That's not an easy arena to dance in, or to playground to play in, when you sit there and tell architects no limitation, let's see what you want to do, or let's see what you could do. In terms of people think Krista Curva curving, and we'll talk about the curving, and it's great, but another thing you guys do very well and frequently is oversized units. Have you thought about putting together some type of rule book or playbook in terms of, here's your boundaries, or this is the playground you could play within, but here's your constraints? I know you talk about always kind of wanting to push the envelope, but at some point, do you have internal metrics or internal rules in terms of, you can go this wide, but as soon as you get this tall, it's not going to fit on a crate, or you can't handle it within the plant? When you get initial inquiries, and especially you, Patty, you probably are able to just like swat them away with the architects, like, not happening, can't do that. How does that decision-making framework look?
Well, we do have some parameters in place that have been standardized, and because of this, you get the same question over and over. But even though every project is different and every requirement's different, so we've put some parameters in place saying, for example, just on curved, we'll tell you, okay, if you want to go this girth, then you can go this height, and based on these thicknesses, these are your minimum radiuses. And then if you want to go with annealed, these are if you want a special shape, you must go annealed. That's your sizes there. So we've got basically those parameters set in place. We've got PDFs that we send out, and it's part of a lot of times it's part of my initial conversation with them, so that they see it as they go back and talk to the design team, and they're looking at what the possibilities are, because that's what they call is this possible? Is that possible? Yes. Well, then how much bigger can we go? Well, you can go this wider, but you can only go this height. So again, those are really good tools that help us, so that when we are having the conversation with them, they're able to look at it and understand it. So we go through it with them. But at the same time, there's always a little asterisk that says, if you want to push it a little, call us, let us see your project, because it may be possible. There's been so many different instances where if there's the time, if we've come into a project from the very beginning and it is very unique that maybe one or two people, the entire world could probably make it, it's just a matter of doing a lot of testing and prototypes, and which coating is going to work, which coating can you stretch out this much, and that, so forth and so on. And what modifications, if you make a slight change to the radius, it really is minimal when it comes to dimensions. So yeah, that's why we don't want to put it down as these are your set guidelines. There's always that little space for room, but overall, I think that covers the gist of it.
And Javier, how much you want to make Javier's blood boil, basically, is how far you want to push it.
Yeah, I love pushing it. I mean, if it wasn't for that, how many jobs we wouldn't have done? Right. I mean, there's so many, and how many, and they're out in publications, and I mean, seeing it to life, I mean, it's something that's, I'm just very proud of and privileged to have been able to do, and thankful to Javier and the team to make it happen. Yeah. That's the other thing is the pressure of making sure you get it done right, and then getting it done on time. Because the deadline doesn't change, and things will happen.
Yeah. We get to do a lot of trials internally in the factory, just trying to see how it fabricates, trying to put something together, see if it's gonna be we're going to be able to put it together and have the aesthetic qualities that the product requires. So that there's a lot of trial going on always, as far as what we can make in terms of fabrication, and that happens all the time. And these trials are making sure that we can fabricate the product. That's basically what we're doing.
Well, this is a very vague question, but generally, do you think the design community has a strong foundation or understanding around limitations with curved glass, or do you think it's no man's land? And well, they heard these restrictions, but they were talking to this glass fabricator who doesn't like to do this, so they were steering them. You know, a lot of times when you have conversations with a certain architecture office, sometimes you could tell who they've worked with in the past based on the parameters or criteria that's been fed to them.
They always want a second opinion. Second opinions are always key. And you can tell if it's someone that's coming to you and is just asking every single question from the very beginning, just trying to understand curved glass, not understanding the processes. And they are more open to, taking you, and you are going to guide them and help you through it. Then you've got some that have a lot of experience in it. They already know what you're capable of, but I want to do this. You've got those. So I don't like saying no to them either, like I was saying, but then it's what's possible.
Adrian, talking to architects for us, it's very, very, very important, and it's very eye-opening. Going back to a question that you did previously, in which is how do you go about in machines or types of processes that you decide to make. It has to do a lot with our conversations with architects, because that helps us to understand what is it that they want, what is it they're looking for, what is it that they're trying to design, and for us that's like fuel that we use to fuel our future, our operations. So talking to architects is very important. We love doing it, and it allows us to really envision the future, put it that way.
What do you think scares people about curved glass so much? On the market side, and maybe that could be driven by bad experiences or poor outcomes in terms of expectation setting, but also from the fabricator side. I mean, I watched the process and it's pretty badass. We could say that here. And you pointed and I looked and it showed it was red hot and it was being bent, and then it comes out and they have to put it next to all the different to make sure that they got the right radius. I mean, it's very cool, but is it just a matter of having the equipment or not, or does it go way beyond that?
It's easier to sell the idea of curved glass to an architect because, again, they want the look. They don't want something segmented. They don't want something rigid and very hard. Those details of a hard piece of glass creating that nice curvature. So that part is nice that you're able to sell that. The main thing is this big myth when people come into the pricing aspect of it. That's the main thing that people say, oh, well, I heard it's 2 to 3 times as much, or it's this. Well, we're not really doing a job where we're going to do a flat piece and then we're going to compare it to a curved piece, right? But, we're doing a scope, we're doing a project. So there is going to be an increase in the job, a certain percentage. But the idea is understanding that it's not the way it's delivered. The message of pricing is delivered. And I think that's really important. And then another thing that helps us is when an architect is presenting to a client a piece of curved glass, we love to put nice mock-ups and samples in front of them so that they see that what these percentage of increases or adds to the building, this value added, beautiful aesthetic, what it looks like, and to see that it's worth it,
So what really is driving cost so people can better understand? Because I think you can sell the look of it. Everybody wants their building to stand out today. And at the end of the day, the facade is the bridal dress. So, it's going to catch everybody's eyes. But whether they have a curved corner or something special at the podium, I think if you can visually see it, you get it. But I don't think people fully understand how manually intensive from a labor standpoint the curving process is. So I don't know. Can you talk a little bit on that?
I want to add something to what Patty said also. It's nowadays, I don't think people are really afraid of curved glass. They would like to understand more. They want to learn more. They want to do more research on it. And one of the things that have helped a lot compared to, say, 30, 40 years ago is that, actually 20, is that coatings can be curved now, which wasn't the case before. So now you could have a very beautiful building with curved corners. And in the past, to keep the aesthetics, to keep the look, you would have to segment the glass because you don't want to break the look of the coating on the flat facade. And now you can do it. You can use a coating that could be bluish, silverish, whatever you call you want, and it can be curved, and it can look the same as the flat glass in the building. So I think that's a very important thing that technology has allowed us to do in curved glass.
Let's talk more on that. That's an important point. So on a flat piece of glass, you have a coating or tint on
Right,
number two, whatever the pattern is, or
right,
you let's say you're having bird-friendly glass. You
right.
have a frit pattern on one, coating on number two. You're saying for the curved portion, historically, either you couldn't use a coating or you'd have to place that coating on a different surface.
Yeah, so yes. So before coatings were made in a machine, well, same sputter coating machine that as today, but uh, the last 20, 25 years, I mean, don't quote me on this, manufacturers of coatings have developed, to put it that way, a protective layer on the coating, which allows us fabricators to heat up the glass to a temperature in which it's going to curve or temper without damaging the coating. If you take an older coating, like the ones that we used to use in the 90s, 80s, at least here in Mexico, and you throw those into an oven, the coating is going to burn. And nowadays, the post-temperable coatings, that's how they're called, they can be tempered or fabricated after the glass has been coated. So you have to temper the glass first and then put the coating. And nowadays, it can be either way. And so that has allowed for buildings to have curved corners or curved details and keep the same aesthetics, keep the aesthetics of the flat glass and the curved glass because you're using the same coating on both the curved and the flat glass. Um,
So that protective film that they apply, let's say you guys are ordering just numbers, 200 sheets of glass from Vitro, right?
right.
And 30 of them are going to be curved, 100, whatever. The rest, did I say 300? The 270 are not. For those 30, are they applying a specific film just for those units, or will they just do it uniform throughout?
It's uniform. Vitro or Guardian or any other coating manufacturer that manufactures coatings that can be post-tempered, they basically fabricate their coatings to be post-tempered. So it could be tempered flat or tempered curved, basically. So it's the same product that we would receive to run it flat or to run it curved is the same product.
So let's say you're doing a convex versus a concave curved unit. Either way, you are still running it on the curving line the same way. Are you just flipping the glass just based on which direction the curve wants to go?
Well, now you touched on another one. So if I go back, not 20 years now, if I go back, I don't know, 5 years now, curved glass, curved tempered, could only be made in the convex shape and have the coating on the second surface, but on the convex side. And now there's new technologies that we have invested on in which we can have the coating on the second surface, whether it's concave or convex, it doesn't matter, and keep the same aesthetic on an undulating facade or on jaws where you want the glass to be concave instead of convex. And this is pretty new. So this is another limitation that was lifted a few years ago. And the key here is that the coating, it has to be away from the rollers always. It cannot be in touch with the rollers. Coatings are delicate. I mean, when I said protective film, I don't mean an actual film. I mean, I don't understand exactly the chemistry of the coatings, but it's something with the chemistry that allows the coating to be run through an oven without damaging the coating. But still, you have to run the coating very carefully because it's still very fragile. So we have to be certified to run coatings. We have to use special handling devices to handle coatings. And when we run the coatings on an oven, the coating cannot touch the roller. So if you flip the coating on top of rollers, it's going to ruin the coating. So the technologies that we use to do concave or convex glass have to do with how the oven is oriented, basically in the way the rollers run and the way the coating runs away from the rollers always.
So that's just the curving process, but then insulating a unit like that. Can you talk a little bit about the process of actually applying the PIB and the spacer and the secondary seal, how that may differ than a typical flat unit? I'm just trying to paint a little bit of a better picture around, you send it through Avenue A, you send it through Avenue B. When you go down B, the curving process, every step of the way has to be slightly adjusted to handle the geometry of a unit like that.
Right, and that's where I go back to your previous question, which has to do with cost. When you the curving of the glass, curve tempering of glass, it's relatively similar to flat. Relatively, it actually has a lot of deviations when you start talking about more difference. When you start talking about different radii and different shapes and sizes, and which happens on many jobs in which you're using different radius, and so your efficiencies really go down. But really, when you start laminating the glass and when you start insulating the glass, these are manual processes. And it's not like we have machines to run long runs in which you can go fast and you have a lot of capacity. So your capacity is very limited, or gets more limited compared to running flat glass. And that capacity obviously increases the lead time, but also increases the cost because there's so much you can process. And going back to your question now, how do you apply the PIV and how do you apply the spacer? In our case, we use a flexible spacer which has the PIV already applied on, and the desiccant already embedded into it. And so we apply it with the special tools that we have developed. And again, I mean, we do use a tool, but it's very driven, or it's driven by a person that is applying it. Then the silicone gets applied with obviously it's a machine, it's a gun, but it's got to be moving. It's a person, and like you said, every curve is different, so you have to have different ways to adapt to different curves in your line. And we don't run long runs, unlike automotive, for instance, in which you have long runs of, say, windshields. We don't. I mean, we're going to be running a job which may have a good amount of pieces, the same size, same shape, but we're going to be running another job which has different ones. And so that's a very good challenge that we have, and we enjoy solving.
When it comes to max sizes and spans, what is usually the driving factor there? Is it handling in the factory, what can fit on a truck? Is it driven by deflection criteria or wind loads? Is it driven by, are we looking at a flat versus a curved unit? Is it just a standard insulated versus laminated? Like, what goes to your head in terms of like A, B, C, D, in terms of, what are the governing limitations just when it comes to how wide or how tall can you go?
You want to go
I
ahead,
think the basis I always think of is, can we get the materials that size? That's number one. Is the glass available that big? Is the inner layer? Sometimes there's something special, a pattern glass. We get asked about curving pattern glass. Pattern glass is known to not come very big. So then your sizes are usually driven by that. The machines go pretty large. We're set up to run larger than what is provided domestically as far as coated glass, for lamination and for insulating. So those are the main things, is that looking at the equipment. Handling, I think we do a lot of customization when it comes to handling, just because we're so used to doing everything manual when it comes to curved or oversized. Those, like you said, we're known for curved, Krista Curva, the name obviously curved, we've been known for curved, but we do oversized. Those kind of things don't run through those automated lines like your standard IGs. So we're accustomed to having to say, okay, well, maybe we've got to try this type of tooling or this type of table or this type of setup, and those sort of things. So those are the main thing, is being able to get the material, those sizes, and sometimes we can't find it domestically, so we've got to go overseas for glass. And then if it's feasible that size, and then equipment would be the second one after that. Us handling it, or weight limitations, or being able to build a crate, that usually isn't the case.
And deflection would be another one, for instance.
Deflection, yeah.
Deflection. But then it becomes a matter of increasing the thickness and basically the thicker deflection.
Yeah, and then the thickness, of course, is the glass available in those sizes. Right. So yeah, right. Going back to that. So,
what does the experience look like working with unitizer window manufacturer curtain wall company? So selling to a facility where it's going to be prefabricated or pre-glazed versus selling to a glazing contractor where it goes on site. There's some glass fabricators that don't deal with glazing contractors. They'll only go to a curtain wall company or a window manufacturer. The attention to detail, the level of care, the level of handling, is it any different if you're selling to a curtain wall facility versus on site, or you think about it the same way?
We think about it the same way on our end. Now, the questions that are proposed to us and the needs of the client come to us differently.
Right.
Understanding that it's got to be fabricated prior. So guess what? Their main thing is making sure they're going to get the glass on time and in sequence. Sequence is key for them. And understanding that you can't ship glass with back orders with pieces of the puzzle. It doesn't work. So that allows us to understand. But the key is we always try to say, okay, do you have a certain sequence? Do you need it a certain way? When do you need the glass? We try to work through things backwards to understand. But we try to all drive it that way in that manner. Because even somebody who's out in the field and they may miss a piece of glass. Well, maybe they don't have to fabricate it into the system, but guess what? They've got to have equipment to get out there. And a piece of glass, they've got equipment that they're going to have to hold on to even longer, or certain setups, or certain requiring appointments and scheduling around the building. So yeah, we try to just treat it all the same. That way, and plus it would make it a lot easier trying to figure out. Now, one thing I noticed that we may handle something differently is when we get a phone call from someone that's maybe new or newer. So you've got to hold their hand a little bit more. They don't understand how the glass would come. How do you handle it coming out? How do we take it out of the crate? How do we handle the crate? A lot of those questions come aboard with us, even from the beginning with the paperwork, understanding why we need a radius to quote a job. Why do we need, a takeoff? I mean, a lot of those things. So from the very beginning, okay, we're going to have to do a lot of hand holding, which is fine, right? And the idea is eventually you come back to us and I don't have to hold your hand as much,
Right, right.
So
when it comes to glass replacement, I think spontaneous breakage, something that comes up a lot. Maybe accidental breakage, but I think when it comes to spontaneous breakage, when we were walking in the factory, Javier, you told me you think heat soaking tempering glass should be standard practice, and you always recommend it. Now it's up to a project team if they want to elect for it, but everybody's had their personal circumstances or seen instances of horrific events, and so doing whatever can be put in place to mitigate any potential damage or risk is always recommended. How a project team assesses the risk is sort of there, up to them, and depending on the elevation or the exposure, etc.
Right.
When it comes to I'm sure you've experienced spontaneous breakage in your career. Maybe not project specific. You've seen it around. You've spoken about it. You've heard about it. Is there an easy method of tracking? Okay, it's that unit number 37 on the west elevation. We produce it on this day. We got this float glass from this supplier. Going back and being able to try to identify the root cause and having like an easy way to track exactly when it was produced, and we can go back and look at the batch number and the silicone we used and the surrounding conditions that day, and just go and look at all the logs. Is that stuff that's tracked and can be measured easily?
Yeah, something that can be tracked very easily into the factory. You can determine when you made it. You can review how you run it through the tempering oven or the lamination line. Yeah, that part it's easy to do. You need some information from the customer, obviously, but you can track it down with our internal systems. And this is something that we've been able to do for many years. We've updated our systems, upgraded our systems, but this is something we've been able to do for many years. Now, the thing is trying to track down the root cause of the breakage. It's a completely different story. And that's when it comes to breakage, figuring it out on glass, it's a very huge task to perform. That's one that in which coming up with the final cause might not be possible in most cases, in my experience.
What's challenging is it can go from how it was handled. Is there like a microchip or crack or abrasion during the handling process or on site? Thermal stress in terms of shading elements around the perimeter. There's so many factors that could come into play that it makes it super challenging. Even something in terms of like scratches and abrasions, I see to be very subjective in terms of what is or is not acceptable. They have standards in terms of standing a certain number of feet away from the glass and viewing it, what is or is not acceptable. Do you think that's clear in terms of, from your eyes, something you guys can explain or communicate to customers? Do you think it's like a very gray area? Because, if an owner's spending $25,000 on a single piece of glass, they don't want to see any imperfections.
What do you say to that, Patty?
What I say is a lot of times they know the standards that are in place. We've got documents that we'll submit and let them know to educate, these are what the tolerances are. But a lot of them know what they are, especially when they're doing really high-end, unique projects. But obviously they know that in this particular case, that's not going to work for them. It's not going to work for the client. There are certain projects. When I hear that we're doing a museum, I already know, very high-end. We're going to go above and beyond. If we're doing glass for above and beyond. If we're doing glass for a high-end residence, way above and beyond. I mean, airport control towers, and theirs isn't so much about the aesthetic because we don't want to see it. It's a necessity because of what can happen in the requirement of the glass and what they're looking out at, and using it as that barrier of glass, using it, looking it out into the sky and confusing it for something else, right? So that's the thing is that majority do know, and they just want to see if we can go a little tighter, or the fact that they're coming in for a second opinion. Someone else said they can't, but we know it's possible, right? That sort of thing happens quite a bit, I would think, right, Javier? I mean,
Yep, that's absolutely right. Now, I think that it's very important that we provide, it's about the looks, right? That's what we said before, glass about the looks. Now, so it's very important that we provide products that are pristine, they're very good, and there are standards to measure things that are pretty subjective, like scratches, like you mentioned. Especially those are very subjective. There's ways to control and mitigate scratches, but if you start really looking and digging, you're going to find something. And so it really is about looking. You want the glass to be beautiful. You want the glass to provide light, to provide transparency, but you want to look through the glass in the end. So there has to be also a certain amount of reasoning when it comes to becoming overly critical,
Scrutinizing.
Yeah. Going back to scrutinizing. That's the word of the day.
Overly critical. Yeah, picky. It was a picky. Okay. I was trying to find a nicer word. Overly critical of looking at aesthetic things like a scratch or like something very that you can only find once you start looking for something. Remember, he who searches is going to find, right? So you can always find something.
I think that also goes back to why we encourage visits to the facility, to understand how you're handling this glass and to actually see the glass. And if there's something that they're looking at, that way we can communicate face to face and seeing, is there something we can do to make it more to what you're looking for? Or now I understand why you have these parameters in place and why I'm going to be able to find certain things. It's just, I think it's critical when it's certain unique projects like that, those high ends ones that I was mentioning.
There's a lot of, at least where I come from, too far north, there's a lot of scrutiny around the battle of the wall and wanting to lower the window to wall ratio. And the glass industry has been combating that and saying, no, we want more vision area, we want more glass, blah, blah, blah. I think the messaging is wrong there in that glass can be transparent and beautiful and make you feel like you are interacting with the exterior environment. But there's also very unique ways to incorporate frit patterns and, that fabric interlayer that we were looking at. Different ways to still have an all glass aesthetic, but appease to either these aesthetic requirements or performance requirements as it relates to visual light or solar shading or solar heat gain coefficient, and blend those two together to still achieve that look. Is that something that you think has been a theme on a lot of your projects?
Yes, I believe so. You're always going to have, the majority of the time, there's always going to be some sort of spandrel. Sometimes they don't want it to be such a hard linear pattern. They want it to kind of, blend into the rest of the glass, or sometimes bird friendly. They know they've got to have some kind of frit pattern of some sort or some kind of design that meets the requirement for that. But then they may not, they want it to have a certain washed out look, or they don't want it to affect the color of the overall unit. So there's a lot that you have to play around from unit to unit, especially when you're looking at gradients, that sort of thing, when they want to play where it's something consistent from one piece to the next, to sort of soften the look of the glass from one unit to the next piece of glass. The other thing is color matching too. You've got a piece of low E in the middle of all of this, and then they want a certain look. You've got to make adjustments to your color to make sure, because again, you are viewing color behind you're using paint or frit or anything behind, glass itself, which has tinting of some sort, no matter if it's Starfire, low iron, any other ultra clear, any type of glass that has less iron content. But then you also have a coating. And then you've got the reflection from it. So that definitely does play a big part in it. So we get asked about that quite a bit. And the ability to make modifications of, well, some fabricators may say, this is what it is. These are the standards. This is, there's no adjustments from that. When, we may say, yes, we can help you give the change, a change to your look, or soften it up a bit, or, tweak your color, just whatever we got to do to make you smile in that aspect,
So
let me complement that. I mean, there's a lot of things that we can do with glass. You can make it opaque, you can make it color, you can make a lot of things with glass. And one of the things that we think is very important is that and glass is a beautiful material, it's a beautiful product, but it's important to know how to use glass too. And that's something that, as much as we'd like to have a house full of glass, I mean, you have to take into consideration the downside to having a house that is all covered in glass. And so it's important that glass is used in a way that is intelligent, in a way that is smart, that it's going to make sense for the end user, and that it's going to look nice. The building's going to look beautiful. You're going to have these views. You're going to be protected from the environment. You're going to have light. But let's use it in a way that is smart for the end user too. That's something that we also like to preach or to offer to our customers.
You know what? I was gonna egg you on for more questions, but I think that's a really nice note to end on. So Javier and Patty, thank you both for coming on. I really enjoyed this conversation and looking forward to featuring more of what you guys are doing behind the scenes.
Yeah, absolutely. Thank you. Thank you so much. Yeah, I'm excited too.
You can drill us with your questions anytime you want, Adrian.
Yeah, we love it.
Great. Thank you.
Thank you.
All right. Bye, guys.
All right. Bye, guys. Bye.